Okay, so this is where we left off last class. Quick reminder. So what we're doing here is we're looking at C, your y-intercept and your x-intercept. So we have a line passes through the x and the y-axis. Identify where it touches the y-axis, that is your y-intercept. Identify where it touches your x-axis, that is your x-intercept. All right. So what we're going to do today is you're going to look at a little revision on the nature of single variable equations. All right. So remember, this was a prerequisite. What we're going to do is we're going to just give you a little review, okay, to make sure that whether you had learned it before and it didn't stick, whether you had learned it before and you forgot, or whether you didn't learn it before, just to give you an idea of what you need to be able to do before we move further. All right, so I'm going to give you 4 types. So I'm going to refer to the first type of problem as type 0. This is just my terms, okay? So if I have something that looks like this, x plus 3 is equal to 10, and I say solve for x, you must be able to do that. Let's pretend you don't. Let's start from scratch. This is what we have to do. We want x on a side by itself. We're trying to solve for x. Problem with that right now is that we have this. This is on the same side of the x, and I got to get rid of that. So what I want to do is I want to subtract 3. So in effect, what I'm going to do is I'm going to say x plus 3, which is what is there. Then I'm going to subtract 3. And if I do that, then I'll have x plus 0, which is just x. And so if I follow this process, I end up with getting x by itself. But right here, this is considered magic, because where did this minus 3 come from? I know why it's there, but I don't know where it came from. Because of that, I have to do the same thing on the other side. So I have to say 10, which is there, minus 3. Okay, and so this becomes 7. Hence, x is equal to 7 is my answer. Okay, so this is what happens when I have a situation like this. Now, there's a terminology here that we use, and that terminology is called transposing. And what I did was I transposed the 3. I took it on the other side. Now, this is all the process, the inner processes that goes on there, right? But I could have worked this problem like this. I could have said x plus 3 is equal to 10. I'm going to transpose the 3. If I transpose the 3, if it was positive on this side, it will become negative on this side. So x then becomes 10 minus 3. Hence, x is equal to 7. Okay, and this is in effect what we did here, but this is the concepts behind what happened there, why it became minus 3. Okay, similarly, if I had x plus 7, right, let's use a negative number, x minus 7 is equal to 12, then I'm going to transpose this minus 7 because it's in my way. All I want on my left-hand side is x. So if I transpose this minus 7, what I'm going to end up with is a plus 7 on this other side, because it was minus over here. So now x is equal to 19 would be my answer. All right, so you want to get that in your notebook. All right, again, this is your first type of 4 types that I'm going to show you. Get that in your notebooks. All right. Also, this particular video right here, even though it's module 2 of our graphing, this is a very good module. If you know somebody who needs help with just the basics of single variable equations, I haven't done a video as yet that is dedicated simply to single variable equations, but I'm taking my time with this section here. And so if you know somebody that might be able to utilize this, We're not assuming any previous knowledge here. Okay, we're not assuming any previous knowledge. Share this video with them. Okay, of course, you want to give this video a thumbs up. Subscribe for more videos. All right. All right, so let's move on. Let's move on. Let's take a look. We're still on type 0. We're still on type 0. Again, this is just my terminology. I'm just doing 0 to 3 for 4 different types, right? So let's say I had x plus 14 is equal to minus 2. All right. So we want to find x. Okay. So what happens here now is I'm going to transpose. And so x is going to be equal to minus 2, which was already there, minus 14. See, because this was positive 14 over here. So I'm transposing it. Remember, make reference to this right here if you want to understand how transposing really takes place. All right. So we transpose that. And this right here is what I need you to know. Minus 2 minus 14 is minus 16. I know some people have some issues with this. If you are one of those persons, you want to maybe make a comment on there so that maybe I can consider creating a little video to help other people with that. Or if you don't want to do it publicly, drop me a message. You have all my contact information. Maybe we can work something out. But you would not want the hill, the little mountain, little bump in the road of not being able to handle negative numbers to stop you from going ahead and spreading your wings in learning this graphing situation. All right. So let's look at one more example here. What if I had, let's say, x minus 7 is equal to 0. How do we handle that? Well, we handle it the same way. We handle it the same way. And this is where you can hit pause and try it for yourself. And then hit unpause and then see what I have here. But the same situation applies. We're going to transpose the minus 7. So I'm going to have x is equal to 0 plus 7. We don't even have to write the 0 there. But notice that this becomes a positive 7. Hence, x is equal to 7. All right. And you're going to see how and why this is going to be very helpful for you. All right. So let's look at a different type. Different type of problem. Type 1, if you will. What if I have 3x is equal to 12? Now, if you're thinking transpose the 3, yeah, this is a little different, right? You see, when we looked at the transposing situation, it could have worked because if I had x plus 4 is equal to, let's say, 8, this plus 4 was a problem, hence I just had to subtract the 4 from here, but I had to subtract the 4 on the other side to make it work. If I subtracted a 4 from here, what I ended up with was 0. X plus 0 is equal to 4, hence x is equal to 4. But what I did was kind of like the opposite operator to what was here. See, right here, this was plus, and that's what helped me to determine that I needed to subtract. So I'm going to use a similar concept here. Right here, this is 3 multiplied by x, right? This is 3 multiplied by x. So I have to do something about that because I don't want to find 3x. I want to find x. So the opposite, if you will, of multiplication is division. So if I were to divide by 3, then this would cancel and I would have just x over here. But if I divide by 3 on one side, I've got to do the same thing on the other side. Otherwise, it's what? It's magic. And hence, x is equal to 4. So how about another example? How about if I had 5x is equal to 25? Then, well, I've got to divide both sides by 5. I've got to divide both sides by 5. If I divide the left-hand side by 5, I'm going to be left with x because that's the reason I divided by 5. 5 divided by 5 gives me 1. 1 times x is x. So this is going to be 25 divided by 5. Hence, x is equal to 5. Okay, how about another example? How about if I had negative 6x is equal to, let's say, 21. Negative 6x is equal to 21. No problem. My coefficient, which is that thing right here, that is multiplying my x. This is called a coefficient. Is minus 6. So I've got to divide both sides by minus 6. That's the only way I'm going to end up with just x. I'm not looking for negative x. If I divide by just 6, what I'm going to be left with is negative 1x, which is negative x. But I'm not looking for negative x. I'm looking for x. So I've got to divide both sides by negative 6. So if I divide this by negative 6, then I've got to divide this by negative 6. These cancel, so I end up with just x, and this then becomes 21 divided by negative 6. Now, 6 doesn't go into 21 evenly, but I can reduce it because 3 goes into both of them, right? 3 goes into both of them. 3 into negative 6 is negative 2, and 3 into 21 is 7. Hence, I end up with minus 7 over 2. And in case you're wondering, 7 divided by negative 2 is the same thing as minus 7 divided by 2, which is the same thing as negative 7 over 2. These are all the same things. As long as there's one of them that is negative, the whole thing will be negative. Okay? All right, so let's try another one. Let's try negative 2x is equal to 14. Okay? And then let's try negative 4x is equal to negative 16. So I give you 20 seconds to work on these, right? And then I'll come in with a solution. All right, I know that's not 20 seconds. Let's just call it 20 seconds, right? What I'm going to do here is I'm going to divide both sides by negative 2. So x is equal to 14 divided by negative 2. Hence, x is equal to negative 7. That's my answer. X is equal to negative 7. Over here, I'm going to divide both sides by negative 4. So I'm going to have x is equal to negative 16 divided by negative 4. Hence, x is equal to positive 4. Why positive? Because a negative divided by a negative gives me a positive. So I end up with a positive 4. 16 divided by 4 is 4. Okay? Good. We're making good progress here. Now, these things you need to get some practice on, regardless of whether or not, unless you've been using it very frequently, whether or not you've learned it before or not. These are the type of things that are easy to go away, right? If you don't use them. So I want to get some practice in there, right? Let's look at another type. All right, so it's going to call this type 2. This is really my third type. I don't know why I do that stuff. So let's say I had 5x minus 7 is equal to 23. All right, now it's kind of like a combination of type 0 and type 1, right? A combination of the first two types, right? So there are some rules here. There's some rules here. Before we mess with this, we want to get rid of this. This has no x in it whatsoever. So let's just get rid of that. And notice what's in front of that. This is a minus sign. This isn't being multiplied by this term. So I could transpose this, right? So that's what I'm going to do first. So I'm going to end up with this. I'm going to say 5x, because now I'm taking this over here and transposing it. So it becomes 23 plus 7. So it was negative over here. It becomes positive over here. So now I'm at 5x is equal to 30, which now resembles something that I'm familiar with, right? I'm familiar with this, right? So what I'm going to do now is I'm going to remember that the coefficient here is 5. I've got to divide by 5 on both sides. So I'm going to get x is equal to 30 divided by 5. X is equal to 6. X is equal to 6. I'm going to give you another example right here, right next to this, so you can keep this up here and take a look at it. But remember, you're expected to have a notebook. You're expected to have these stuff in your notebook, okay? So here's another example. What if I said 2x plus 8 is equal to 12? All right, so give that one a shot. 2x plus 8 is equal to 12. Give that one a shot. All right, so again, before we touch the 2x, we want to transpose this right here. And in doing so, what we're going to have now is 2x. We did nothing to that yet, is equal to 12 minus 8. Hence, 2x is equal to 4. And now we have to divide both sides by 2. So x is equal to 4 divided by 2. X is equal to 2. Again, slight reminder. You want to hit a thumbs up, a like button on the YouTube page, all right? And you want to subscribe because I put videos up here almost every day, okay? But what I want to mention specifically right now is that this section right here is not a part of graphing. It's something that we should know. Having said that, there are students who struggle with single variable equations. Let them know where they can come and get help. Share this video with them. You don't have to share the entire playlist. You don't have to share the entire course, but this module 2 right here is single variable equation made easy. Very simple, okay? All right, let's move on to the third type. Let's move on to the third type. Sorry, the fourth type, type 3. Confuse myself with this nonsense. All right, so let's go with x over 2 plus 4 is equal to 12. Now, this isn't so different. And by the way, don't hyperventilate. Don't get scared because we see a fraction here. This is made easy for us, right? Let's just take it step by step. This is very similar to the one we just did, except this is a fraction. That's the only difference. Right here, we have a fraction. And by the way, x over 2 is the same thing as 1/2 x. Just keep that in mind. Keep that in mind. But before we start messing with our x, what did we learn from the last type? What did we learn? What did we learn? This 4 has no business over here. It has no business over here. It doesn't have an x in it. I'm looking to solve for x, so I need x on the side by itself. So I gotta transpose this. I can transpose this because of this sign right here. This is a plus, I transpose it, it becomes negative, okay? So what I wanna do here now is I wanna say x over 2 is equal to 12 minus 4. Hence, x over 2 is equal to 8. All right, now, this is the part that scares a lot of us, right? The fraction, right? Look, nobody loves fractions. Nobody. Unless it's a fraction of a very, 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 very large sum of money. We don't like fractions. Okay? Maybe food too. Maybe if it's a fraction of a very, very, very large pizza or something, right? But we want to get rid of this fraction. Remember, if this thing was 2x is equal to 8, we would have done the opposite, right? What does that mean? This is multiply, we would have divided both sides. That's what we would have done. The concept is the same, guys. The concept is the same. This is x divided by 2. So what do we have to do? We're going to multiply by 2. See, if we do that, then these cancel. And then you have to multiply by 2 on the other side as well. Now, quickly, let me show you what I mean by it cancels, right? If I have x over 2 and I multiply that by 2, that is the same in terms of fractions as x over 2 multiplied by 2 over 1. That's what a fraction means. A whole number is just that number over 1. And when we multiply fractions, we multiply the numerator and the denominator. So I'm going to have 2x over 2, hence these cancel. So if I'm dividing by 3 here, then I'm going to multiply this by 3. And if I do that to one side, I've got to do it to the other side. So coming back to our problem here, these cancel, and I'm left with x is equal to 16. Easy like a Sunday morning. Easy like a Sunday morning. All right, let's try another one. Let's say I had x divided by 4 plus 3. Let's say this was equal to 19. Right? I give you a pretend 20 seconds to solve that. You probably want to pause the video and try it on your own and then come back and let's see what we have. All right, so let's just say 20 seconds just went by, okay? So the first thing we want to do is you want to transpose this bad boy right here, right? We want to transpose that. That's the first thing we want to do. So we don't touch this x over 4 yet, right? So we have x over 4. Notice I try to keep my equal sign under each other. It's very neat, very orderly. I'm pretty sure you've heard that from every math teacher you've had. So I'm going to transpose this so this becomes 19 minus 3, right? It says 19 minus 3. Over here it was positive. And I transpose it, it becomes negative, right? So now I have x over 4 is equal to 16. And what I'm going to do here to get rid of this 4 is I'm going to multiply both sides by 4. I choose that to get rid of the 4, so I know I'm going to be left with x. And this is going to be 16 multiplied by 4, hence x is equal to 6 to 4. All right. And so from here, all you need to do is just practice, get your practice on, get your practice on, get your practice on. I can help you with that as well. Okay. If you want to get some practice problems, I can help you with that as well. But let's get back to the program at hand. Let's get back to finding C. Okay. So the equation of a straight line is given by this. Y is equal to mx plus c. This is the equation of a straight line. You want to get that in your notebook. This is the equation of a straight line, where y is your y value, x is your x value, m is your slope, and of course, you know another name for slope is your gradient, and c is your y-intercept. Okay, So this is your general form for the equation of a straight line. General form for the equation of a straight line. Okay. So if I had an equation that looks like this, if I said y is equal to 4x plus 6, here's what I know. I know m is 4. And I know a couple of things also, right? I'm bragging, all right? This is me inside your little head bragging, right? Oh, this is positive. 4 is positive. 4 is positive. What does that mean? That means it has a positive growth. What does that mean? It means as I go from left to right, as I go to negative, from negative to positive infinity, this graph is going to go upwards. And it's going to be somewhat steep because it's 4, but you have to tell me another one for me to tell you if it's steeper or less steep, something else, right? But it's going to be up there. It's going to head north to the heavens as this thing goes to positive infinity. Yeah, I know that. I know that because I just took this course, right? But what else do I know? I know that this thing crosses the axis. This right here is C, right? So this thing crosses the y-axis at 0, 6. Kind of lost me there. Sir. Yeah. I'll explain it again right now. Just understand that this is an equation of a line, and from that equation, this is what I could tell, right? So let's go back and do a quick review of something we did in the last module, okay? If I have something that looks like this, right? So this is my y, this is my x, right? And I have a line that goes like that. Right here, it crosses the y-axis. Right there, where it crosses the y-axis, the x value is 0, 0, c. Whatever that y value is right there is what c is. So if this line had the equation y is equal to 4x plus 6, if this was the equation of this line, c would be 6. And this point then would be 0, 6. Because c represents the y value in the y-intercept. So if I had another line, let's just say for argument's sake, I had another line. Let's say a line that went down like this, and we know what that means, right? We know that its m is negative, right? Yeah, we know that. It crossed right here, right? Then we know that whatever the equation of this line is, x value is 0, and wherever the c is, let's say for argument's sake, this equation was y is equal to negative x, negative 2. Then as you can see right here, this is c, negative 2. So this would be 0, negative 2. And it has to be negative because we're looking at the graph and it's below the x-axis. So down here is where we have our negative values, right? So this is, again, just conceptually. Let's see how this works in an actual problem, right? So I say to you, I have an equation. It says y is equal to mx plus c. And I say m is equal to 2. And I say this equation passes to the point, let's say 4 and 7. It passes to this point, 4 and 7. So you're being asked to find c. Now this is a problem that you're given, right? So let's go, let's boogie. Here's what we do. We look at what we know. We know that m is 2, so y is equal to 2x plus c. Good, very good first step. Second step, When x is 4, y is 7. Now, let's get into some math now. When x is 4, y is 7. So wherever y is, we're going to put 7. And that happens when x is 4. So what is our unknown now? C. So remember, we have a single variable equation, meaning there's only one unknown, one variable in this equation, and we have to solve for it, right? We have to solve for it. Now, this problem right here, if you're sharp enough, some people might already realize that I could just flip this around, because what this really is C plus 2 times 4 is equal to 7. See, that's the same thing if you read it backwards, right? All I did was put this stuff on that side and this stuff on that side, right? But even if I didn't, right, I'd work it out the same way. Let's work it out this way. C plus 8 is equal to 7. And so now I got to transpose this 8, right? So I'm going to get C is equal to 7 minus 8. Hence, C is equal to minus 1. C is equal to minus 1, right? If we did it over here, we will do the same thing, right? So this is still 7, and this is 8, right? 8 plus C. But I want C on a side by itself, so what I'm going to do is I'm going to have to transpose this 8. But this is positive, right? This is positive because it has nothing in front of it, which means it's positive. If it was negative, it would have a negative there. So when I transpose it, it becomes negative, right? So this now becomes 7 minus 8 is equal to C, hence minus 1 is equal to C. Same answer, right? That's the same answer I got, right? But this is why we needed to be able to solve single variable questions, right? So remember the question here. So in your notebook, you want to write the question, right? You're given that the equation of a line has a slope of 2 and it passes through the point 4,7. Find C, right? And just so you know, what we have found out is that this thing intersects the y-axis at 0, minus 1, right? C is the y value of the y-intercept, right? 0, minus 1. As we get further into this course, you're going to be able to sketch this just with this information right here. You're going to be able to sketch this graph, right? So this is the answer we're looking for. This is the answer we're looking for. And this is what it means. All right. So let's look at another problem. All right. So I know that M, let's say, is equal to minus 2. And I know that this line passes to the point, let's say, minus 4 and 12. And I want to find C. I'm looking for C. So I always start with my general equation. Y is equal to mx plus c. I always start there, okay? Then I plug in what I know. I know, for example, that m is minus 2. I know that it passes to this point so that when y is 12, and of course, m is minus 2, x is minus 4. Right? So now this becomes 12 minus 2 times minus 4 is positive 8. So once I do my transpose and I take the 8 over here, it becomes negative. So I get 12 minus 8 is equal to C. 4 is equal to C, hence C is equal to 4. So this thing crosses the axis at 0, 4. Now you're probably saying, okay, this crosses the axis above the origin, but m is 0. M is negative 2. M is negative. That's okay. It's going down. Let's give you a quick example of how this could happen. Quick example. All this means is that at this point, which is 0, 4, all this means is at this point, this thing was going down. See, it's still going down, but it passes there. That's all it means, right? That's all it means. Right? Let's get back to what we did here. What we did here was basically from this step, we went to this step, which is y is equal to minus 2x plus c, because m was given as minus 2. And then we know it passes through this point. So I know that at this point right here, this is what happens. When y is 12, right here, x is minus 4, right there. Okay, I utilize that knowledge to find c, right? Let's try one more. Let's say I tell you that there's a point 5, 1. And it's on a line which has a gradient of, let's say, 3. I want you to find c. Right? Find c. Give that a shot right quick. Find c. So I'm going to start with my general equation of the line. Y is equal to mx plus c. And then I'm going to start putting what I know. Y is equal to 3x plus c. And I know it passes through here. So when y is 1, x is 5. And so 1 is equal to 15 plus c. But I got to transpose this 15. Why? Because I'm looking for c. So I need c on a side by itself. So I got to transpose it. So this becomes 1 minus 15 is equal to c. Hence, minus 14 is equal to c. Okay? Minus 14 is equal to c. All right? So again, you want to get some practice in, review these. They should be in your notes, review them, right? And in our next session, what I'm going to do now is we're going to look at how to find m. The next module speaks about how to find m and how to go more in depth with this formula. All right, so that's what the next module does. That's it for now.